So let's get started. Let's not waste any time. Okay, so what I wanted to go through with you, which I obviously didn't get a chance to show you last week, was how to factorize cubic expressions, because you need that in order to be able to solve cubic equations. And the method that I want to teach you might be different from the method that your teacher is teaching you at school. Maybe they're doing synthetic division, maybe they're doing long division. It really is your choice at the end of the day. The reason why I always teach inspection is because it works for every single cubic polynomial. There are situations where synthetic division and long division actually fail to factorize for us. So inspection always works. So that's why this is the method that I always teach my matrics at school as well. Okay, so let us, in order for us to understand where the factors come from, we first have to understand how a cubic polynomial is created. And we obtain a cubic polynomial by multiplying a linear polynomial, such as x plus 2, with a quadratic. So if I take, for example, x squared plus 2x plus 1, if I multiplied the first bracket with the second bracket, this would be what happens. Okay, I'd say x times x squared, so first times first, that would give me x cubed. X times 2x would give me 2x squared. X times 1 would give me 1x. 2 times x squared would be 2x squared. 2 times 2x would be 4x. And then last times last, 2 times 1 would give me 2. So I would end up with a final answer of x cubed plus 4x squared plus 5x plus 2, right? So that is what we are learning how to do. We're starting with the terms. So we're starting at this line over here, and we are putting in the brackets. Okay, so we're working backwards. That's what factorizing is. Okay, so when we have factors and we multiply them out, we start with factors, we end with terms. When we're factorizing, we start with terms, we end with factors, we are putting the brackets back in. So that's what we are busy learning how to do in this situation. We need factor theorem in order to be able to do this, because if they tell us to factorize f of x, for example, as far as possible, they have not given us this linear factor. So the one that I chose here was x plus 2. We don't have that. So you need to sub in values of x that gives you 0 as an answer, right? There's going to be more than one answer, because after all, when this factorizes, it's going to factorize into 3 brackets, all right, or can factorize into 3 brackets. Okay, so one person may find a factor of 2 works, whereas, so when 2 goes in, you get 0, but somebody else might have subbed in -3, and that also works. What that means is that your trinomials are going to be slightly different, but when you factorize at the end, you're going to end up with the same answer. Okay, if you obviously haven't made any mistakes. All right, so when you sub in values, it's got to be a factor of the constant term as well. So in this case, if we've got 6, our factors of 6 would be 1, 2, 3, and 6, positive or negative numbers. Okay, so you might find that when you sub in 1, it doesn't work, but when you sub in -1, it does work. All right, so let's do that. Get your calculators and start off. Okay, try 1, try -1, try 2, try -2, try 3, try -3, try 6, try -6. Okay, what gives us 0 as an answer? F of what gives us 0? There we go, Tsepo. Okay, so when we sub in -1, we get 0 as an answer. What does that mean? What's our linear factor? If f of -1 is 0, what's our linear factor matrix? There we go. Well done. So that means that x plus 1 is a factor of f of x. So what that means for us is that we are able to write f of x is equal to x plus 1 multiplied by a trinomial. Now, we do not know what the coefficients of the terms in the trinomial are. So we go ax squared plus bx plus c, and it's going to be our job to work out the values of a and b and c using inspection. Okay, so recall from my pink example up at the top, I only had one x cubed term. So that comes from multiplying the first term in the first bracket with the first term in the second bracket. So x times ax squared is ax cubed. Then you go back to your linear polynomial and you look at your x cubed term. You can see that it is 1x cubed. So that means that a is equal to 1. You've made your variables the same, so now you're equating the coefficients. Let's do c next, right? The only way that we got this number over here, or this number over here, was when we multiplied last with last. So it's the same story with this. 1 times c gives us 1c, and when we go back, we can see that it was equal to 6. So that means that c is 6. Okay, that's the easier bit, right? The more difficult part is trying to work out the value of b, all right? So the value of b comes from two places. You have to multiply the x in the first bracket with the bx in the second bracket. That gives you bx squared. Then you also have to multiply the 1 in the first bracket with the ax squared in the second bracket. Okay, because remember, there were two x squared terms. Okay, there was this one here, there was the first x squared term, and then there was another x squared term. So it is the sum of those that give us the x squared term in the answer. So we've got bx squared from multiplying x with bx, and 1 times a was equal to 1, so 1 times 1x squared gives us plus 1x squared. And now again, we need to go back and we need to look at the x squared term in our question. It's negative 4x squared. So we're going to make this equal to negative 4x squared. Again, now that we've got our coefficients, we can drop our variables. So b plus 1 is negative 4. That means that b would be equal to negative 5. So guys, what we've got is this. X plus 1 times 1x squared minus 5x plus 6. And then all we need to do is factorize this trinomial as well. Okay, so two factors, both of them negative, and that would do it. Okay, so fully factorized, it's factorizing into 3 brackets in this particular case. All right, x plus 1 times x minus 2 times x minus 3. All right, how does that sit with you? Does that make sense? Are there any questions? Katleho, go for it.
Ma'am, is it okay if we don't use the, what's this, x squared, ma'am? If we use the x's only, ma'am? Like,
No.
ma'am, if you say, ma'am, can I just ask?
Oh, sorry.
So, ma'am,
Sorry, Katleho. Okay, go for it.
okay, ma'am. So, ma'am, you see where you were supposed to find bx, ma'am? I did it in a way that you say 1 multiplied by b, so it's just going to give you x, ma'am, right? And then you say x times c, and then it's just going to give you x. So, ma'am, c is what's that? C is 6, right, ma'am? And bx is the one that we're looking for, ma'am, and it's supposed to
Yes.
give you 1. It's supposed to give you 1. So, ma'am, if we do it like that, is it wrong, ma'am? Because it still gives me the same answer. It's just that it's a different way of looking for it.
Okay, so as far as I know, Katleho, there are only 3 ways that you could factorize cubic polynomials. This is one way, by inspection, or you can do long division, or you can do synthetic division. I wonder if what you're doing isn't maybe synthetic division. But you see, unfortunately, if I can't see what you're doing in front of you, then I don't know. But I don't know of any as far as I'm aware, there's no ways that you can use the X term in this. This term over here doesn't get used in the inspection method.
Oh, okay,
Okay.
ma'am.
All right.
But
Okay. So is it the synthetic? Hang on a second, Natalie. That also works, Katlejo. You'll get the same answer. Okay. So are you doing synthetic? Are you doing synthetic division?
I don't know what it is, ma'am. That's why I'm asking, ma'am, because I just do it that way, and it still gives me the same answer,
Is
ma'am.
that is so the method that you're using, is that something that you've been shown at school?
No, ma'am. No, ma'am.
Okay, all right. So I would just be careful of making up my own methods, because maybe it works for one particular question, but maybe for the others it's not going to work. All right. See, so unfortunately, this is
Ma'am,
a little bit of a drawback because I can't see what you've written on the page. If I could see what you'd written, then it would be easier for me to understand whether or not that would be an acceptable way of doing it. Okay. All right. Yeah, so it's better to stick to traditional methods every single time. Also, the people that are marking your work at the end of the year will also be looking at it from a traditional conservative point of view. So it's better not to go and create other methods in order to be able to do this. Um, okay, so let's give you guys one to try, and then you want me to do one using synthetic division. All
yes,
right.
please, ma'am.
So, all right, that's fine. What I'll do is I'll get an example and I'll do synthetic division with you. What I would like you guys to try, just before I do that, okay, is I want you just to try one of these questions. Okay, so the one that I'm giving you guys to do is, let's just move this over. Sorry, I left my mouse at school, so I'm feeling a little bit okay. Have a look at g of x. Okay, so try this, and then I will try one with you using synthetic division. Okay, so give that a try. There are plenty more on the screen below as well. So there's a couple there that I want to show you too, but try g of x. Yolanda, just give me 1 second.
Let's go, guys. Let's try that. And you guys can use any method that you like. Use any method that you like as long as it works and as long as like mathematically correct. So you are allowed to use such method. Canelo, is there anything you want to say? You are unmuted. Canelo? Canelo, can you please mute then? If you don't have any questions, please let's make sure that we are muted, guys. And when you are done, you can just say done on the chat like this. Charlie and I can see that you're done.
Okay, so I think probably the best one for me to do with synthetic division would be the one that we've actually already done. So I'll do f of x using synthetic division. I'll just let you do g of x first. Okay, Matrix. Okay, lovely. All right, so there's a whole bunch of you that are done already. Nice, good stuff. Okay. All right, so hopefully this has gone well for you and it's made sense. I'll just wait one more minute and then we're going to talk about how we got the answers to this. Okay, now remember, when we talk about our answer, there are people that may have got a different linear factor to you. Okay, so that means that their quadratic is going to be slightly different. Okay, so can I have a volunteer? Who wants to tell us how they did G of X? Kamogelo, go for it, Kamogelo.
Good afternoon. So
Good afternoon.
I found that x minus 1 is a factor.
Okay,
Then-
good.
So I said open bracket x minus 1, close bracket
Mhm.
x squared plus, I used the mx method. So I said plus mx.
Okay. That's fine. So what letter did you use in front of your x squared?
Mx. And I said x.
So did
no,
you say?
No, it's just x squared. Sorry, ma'am. It's x squared.
Okay, that's fine. Okay, so you said x squared.
Yes, then I used mx plus
No
mx
problem.
plus
Mhm.
8. Plus 8.
Plus 8.
8. Yes.
Okay.
Then I multiplied the x times mx, which gave me mx squared.
Sure.
Then I multiplied the x squared and the negative 1, which
Lovely.
gave
So that
x squared minus x squared.
lovely.
So that will equal to 5x squared.
Very good.
Then I got then I divided by x squared, and I got m minus 1 equals to 5, and I found that
Good.
m equals 6.
Lovely. Okay, well done. Okay, so it really doesn't matter, right, that Kamogelo used a different letter to me. Okay, you'd still get whether you use a B or an M or a Q or whatever the case is, that's fine. So Kamogelo, in your final answer over here, what did you end up with?
So I ended with x minus 4.
Sorry, let me just.
No, I'm sorry.
So you ended up with x plus 4.
X minus 4.
Why minus?
Maybe
Because
I did.
because you see here you've got 6x and you've got 8. So then in this bracket over here you can only have positives.
Oh, okay.
Okay. So if your middle term is positive and your last term is positive, then both your factors in inside your brackets have to be positives as well.
Okay.
Okay. But still, that
Yes.
was very good. I mean, if it's the last little thing that you did was your factorizing on your trinomial, that's not a big thing. Okay, well done. That was a very nice explanation. All right,
Okay.
so Pinga, good, well done. Pinga, you'd get a mark for your linear factor, you'd get a mark for your trinomial, and then you'd get a mark for your brackets, all three of them. Okay, so Ayanda, what we're doing on the side there is we're trying to work out the value of m. Okay, so she has already worked out the value in front of the x squared, that it's 1, and she's worked out that the constant term is 6. So this is her on the side over here working out what this m is supposed to be. That's what she's doing. Okay, so that does need to be done. All right, it's easy enough to do it by inspection in our heads to work out what the x squared, what the coefficient of the x squared term and the c term is. But as far as the middle term is concerned, we need a little bit of working out to help us. Okay, so let's go back and use the same example and let's do synthetic division. Okay, so we're going to do this one on the left here. So x cubed minus 4x squared plus x plus 6. Now again, some teachers draw their L's back to front. Some teachers draw their L's the other way. It really doesn't matter how you draw your L when you do synthetic division. Nothing wrong with that. Abulele. I hope I said that correctly. Sorry, I hope I'm not butchering your name. That's not a problem either. All right. So if you had x plus 2, then in your trinomial, you would have ended up with x squared plus 3x minus 4. Okay, which when you factorize it, you would have still got x minus 1 times x plus 4. Does that make sense to you? Okay. All right. So remember, you're not all going to have the same linear factor. If your linear factor changes, all right, you use a different linear factor, that's okay. You're going to have a different trinomial, but when you factorize it in the end, you're going to have the same 3 factors. Okay, so let's do this synthetic division. All right, so I am going to go with black. All right, so what I would do is I would draw myself a backwards L. And then what I want to do is I want to write down the coefficients inside. So in front of my x cubed, I've got a 1. In front of my x squared, I've got a negative 4. Let me not make any mistakes. Sorry, I keep pressing this silly button that's on the side of my pen, and it makes those funny squiggles on the page. Then in front of my x term, I've got a 1. And my constant term is a 6. Now remember, in the beginning, we discovered that minus 1 gave us 0 as an answer. So our root is negative 1, and we are going to write that on the outside. Okay. What we would then do is we would bring this coefficient down to the next line. All right. And what we want to do now is we want to multiply this 1 that I've brought down with a minus 1 that's my root. So I'm going to say 1 times minus 1. That's going to give me minus 1 as an answer. And then I'm going to take that minus 1 and I'm going to put it over here. And then I say minus 1 minus 4. That leaves me with negative 5. And then I repeat my process. Okay, so I'm going to say negative 5 times negative 1. That gives me 5. And I'm going to put my 5 above my 1. And then I'm going to say 5 plus 1, and that leaves me with 6. Okay, repeating my process again. I'm going to say 6 times minus 1. That leaves me with minus 6. Minus 6 plus 6 leaves me with 0 as an answer. And that's what I want, okay, because I want my remainder to be 0 whenever I divide. Okay, and now what I'm going to do is I'm going to use these numbers below the backwards L to write my linear factor and my coefficients of my quadratic. Okay, so that means f of x would be equal to x plus 1. Okay, then as far as my x squared is concerned, okay, so the x plus 1 comes from here. It's this minus 1 over here. That's why I've got x plus 1 over there. Okay, this 1 here is my 1x squared. Minus 5x, so the minus 5x. And then my 6 over there, that would be plus 6. And then I would close my brackets. And now I can go ahead and go and factorize. So it'd be x minus 3 times x minus 2. Okay, and that's no, Nolitando, there are certain situations where synthetic division fails us. Okay, so with your bog standard normal ones, it's okay, but there are certain situations where synthetic division doesn't work. That's why it's nice to be able to do inspection. Okay, but it's up to you. Okay, you, which coefficient, Ayanda? Which coefficient are you talking about? The numbers in blue. Okay, so that comes from the question. Okay, so the numbers in the light blue come from the question. All right, so if I just move that up a little bit. So this one over here comes from the one over there. And this -4 over here is the -4 that's there. And in front of the x, you've got +1, you've got 1 over here. And as far as the 6 is concerned, you've got the 6 over there. That's where those numbers come from. Okay, Ayanda? So it's up to you. All right, some teachers teach synthetic division, some teach inspection. If you've got a teacher that's doing long division with you, that's truly horrible. Not a popular method at all. But yeah, one of these two is fine. Okay, are there any other questions about that? You do what floats your boat. Okay, so I'm taking it that there are no questions. Let's practice a couple more of these before we move on. All right. What I would like you to do, all right, is have a look at these trinomials that I've given you in the block over here. Okay. I would like us to do A, but I'd also like us to do D as well. You want to do one more, Roseanne? That's fine. We're gonna do these ones here. You mean you want me to do it with you, Roseanne? You want me to do C? Is that what you're asking? All right, that's fine. I'm happy to do C with you. It is one that's a little bit more unusual, so that's not a problem at all. Okay, so in question C, I'll do C. Let's just do a little bit more space here. Come on. Sorry, as I was saying, I left my mouse at school. I'm feeling a little bit lost without it. Okay, so let's do C together. That's fine. Tsegofatso, can I do inspection? Okay, so 3x cubed minus 7x plus 4. Okay, so again, what I need to do is use my calculator, all right, to find factors of g of x. All right, so use your calculators to do that and tell me what you get as a linear factor. Oh, that's got a square on it. Your coefficient of your x term would be 0, by the way. Good. Fine, Nolatundo. Perfect. Okay, so x minus 1 is a factor. So over here, I'm going to call this ax squared plus bx plus c. All right? So when I want to work out the value of a, I'm going to multiply x with ax squared. That gives us ax cubed. And when I come back here, I can see that it's equal to 3x cubed. So that means that a is equal to 3 in this case. Okay, not 1, but 3 in this case. Let's do the value of c next. Okay, so I'm just going to make a little bit more space for us here. Okay, now we're going to do the value of C. I'm going to multiply -1 with C to get -1C. And when I go back and I have a look here, I can see that it's equal to 4. So that means that C is equal to 4. When I want to work out the value of B next, I'm multiplying x with bx to get bx squared. And I'm multiplying -1 with ax squared. Now remember, a is equal to 3. So -1 times 3x squared. -1 times 3x squared is -3x squared. We can see that it's equal to -7x squared. So that means that b minus 3 is -7. Take the b over to the other side, and b would be equal to -4. Oh, yes, you're quite right. Sorry, c is equal to -4. Thanks, Penga. That would have been a little bit confusing, wouldn't it? Quite right. Sorry, it's dividing by -1 on both sides. Good. Well done, Penga, for picking that up. Okay, so we've got x minus 1 times 3x squared minus 4x minus 4. Okay, now we need to factorize our trinomial. So this would be 3x, this would be x. Okay. Now we've got to think about our factors of 4. So it would be 2 and 2 or 4 and 1. Try the numbers, the factors that are closer together first, and then work your way to factors that are further apart. So if I put 2 here and 2 here, I can get 6x squared from the outers. So I want minus 6x squared plus 2x to give me minus 4x, and plus 2 times -2 gives me -4. And there we go. It's fully factorized. Okay, so that's how we would do a question like C. Okay, now, Nizoli, you have got all of those correct except the middle one. It would be -2/3. Okay, that's if you were solving a cubic equation. Right, remember we are just factorizing at this stage. Okay, so if they asked you to solve for x, okay, so solve for g of x equals 0, then you can write down what x is equal to. Okay, at the moment, we're just factorizing, we're not solving yet. Okay. Everybody happy with it? Are there any questions? All right, so I'm going to move back over to the side so that we can see those other questions and give you a chance to practice this. If you want to use synthetic division, you're more than welcome. Okay, there we go. All right, so you're either going to try question A or you're going to try question D. A or D, guys? No problem. Try D then. Nicole, if that is your name. No, Pinga, it's not. X minus 1 is not always a factor. Maybe it's just, you know, in a lot of the questions that we've done this evening, it's ended up being a factor, but it's not always, no. I mean, if you think about the one that we did using synthetic division, our first example, x minus 1 wasn't a factor. X plus 1 was a factor, but not x minus 1.
Yeah, when I was in school, I also asked like such a question because every single question had its vector as x minus
It's
1.
one,
But
yeah.
actually, yeah, but actually that's not true. Not all of them will
No,
always
no,
have
no,
this.
no. No, it's that's making an assumption, isn't it?
Exactly. But I was also like that because every single example will have x minus 1 as a vector.
Yeah, yeah, yeah. Even though strictly speaking, that's not true.
Yeah.
Sure, Mihlani, not a problem. That's correct, Nizoli. Okay. So Pinga, you got to use factor theorem. Okay, like Nizoli said, you got to sub a number in, and then if you get 0 as an answer, then you know what your linear factor is going to be. Okay, so Mihlali, I'm just going to scooch over to the side for you quickly. Just take a screenshot, and then I'm going to go back. Okay, hopefully you've got your screenshot. Awesome, well done, guys. All right, so I'm just going to wait a second or two, and then we're going to see what solutions you guys came up with. Let's put D here. Okay. Okay. Anybody willing to offer us an answer for question A? Who did question A and is happy to share what they got as an answer? Don't stress if it's not correct. We all make mistakes. We're not here to judge you. We're here to help you. Anyone want to share their answer for A?
Come on, guys, before I choose. Well, there we go,
There we go.
Nizol.
Nizuli, come.
Thank
Cool. Go
you.
for it. What did you do? Is Nizuli managing to unmute?
Let's go, guys. Yeah, we can do
I
this.
don't know what happened to Nizoli. I don't know whether she was able to unmute or not.
It could be network. I mean, like, this, yeah, let me stop complaining. I was about to complain because I'm load shedded. And it's not even
Okay.
load shedding, it's power.
Oh, that's ridiculous.
I
Okay.
know.
Okay, so is it Ashlyn? Ashlyn, I hope I pronounced your name correctly. You're welcome to give us your answer for A.
Yes, please. You can raise your hand.
So for A, in my first bracket, I had x minus 2, x
Sure.
minus 5, and x minus 4.
X minus
I used
4, and
the
then you had x minus 5
Yes,
or x plus 5.
x minus 5.
Okay, I had x plus 5, but let's just double check. Let's see what anybody else had. Nicole, what did you have? You've got your hand up?
Okay, in my brackets, my first bracket I have x minus 2, and the second bracket I have x plus 5, and the third bracket I have x minus 4.
That's it. That's exactly what I had as well.
Thank
Okay,
you.
so my 5 was also a plus and not a minus. Yes, there we go. There we go. Yeah. Okay. All right. So just a little mistake there. All right. Well done, guys. That was very well answered. Okay. Question D. Anybody want to share their answer with us that they got for question D? Nolatundo, your hand shot up. Go for it, Nolatundo. What did you get for D?
Okay, hi ma'am. I got
Hello.
the first bracket is x minus 2.
Mm-hmm.
The second one is x plus 5.
Sure.
And then the last one is x minus 3.
That's what I got as well. Okay, well done, Nolatundo. That's lovely. Okay, good job. How are the rest of us? Let's see, Keithlin. Okay, so Keithlin, you got x minus 4. Maybe, oh, hang on, maybe I think it was the previous question. Okay, all right, that's fine. Perfect, Keithlin. And Kanyiso, x plus 5, x minus 4, x minus 2. Lovely. Okay. All right, that's fine. Let's do A quickly. All right, so what I'm going to do, okay, because we're all agreeing that it's x minus 2, right? So here we would end up with, this would obviously be 1x squared, right? And then negative 2 times c equals 40 means that c would be equal to negative 20. So that's negative 20 over there. Then as far as our bx term is concerned, we would end up with bx squared, because remember we've got bx over here. So we'd end up with bx squared minus 2x squared, and that would be equal to negative 1x squared. So that means b minus 2 equals negative 1. So b would be equal to 1. So here we've got x minus 2, sorry, that's a horrible square. That looks awful, squared. Then here it would be plus x minus 20. Okay, so matrix, because your middle term is positive and your last term is negative, one bracket has to be plus, the other one has to be minus. It has to be x plus 5, the bigger, because remember 4 times 5 gives you 20, and 5 minus 4 will give you the 1, right? So it has to be x plus 5 because your middle term is positive. So the bigger of the two numbers, 5, has to be the positive one. Then it has to be x minus 4. So x squared minus 4x plus 5x is plus 1x. And positive 5 times negative 4 would give you the negative 20. Okay. All right. Are there any other questions? It's a pleasure. It's a pleasure. Any other questions? Are we all feeling confident? How are we feeling about this now? Are we feeling a little more confident? Thumbs up, thumbs down. How are you feeling? A lot better. Oh, I'm glad to hear that, Tando. No, Latanya's got thumbs up. Shania's got a smile. Nice, Shania. Hope I'm not butchering your name. A lot more confident. Good, Nati. Keith Lynn's happy. Good job, Keith Lynn. Bali's got thumbs up. No, DeAndre, there isn't. Okay, so if you don't know what the linear polynomial is, the only way that you can actually get it is by inspection. Okay. All right, see how I was sitting on the fence, Pinga's sitting on the fence, and P-Ware, good so far. Okay, all right. So the more you practice, the easier it's going to become. Right, if you want to take screenshots, there's B and C and E. You can practice as well. Okay. All right, good. I'm glad that you feel like that. Lovely. All right, so we've only literally got a few minutes left. What I wanted to do was just link what we've been speaking about now to our cubic function. All right, so I'm going to do that here on the side. Do you remember when first time you would have done it would have been in grade 11? Okay, so let's say they gave you a parabola, and let's say the parabola was f of x equals x squared plus 3x plus 2. And they asked you to solve the x-intercepts of f. In order to get the x-intercepts of f, what did you do? If you were going to solve the x-intercept or x-intercepts of any function, what would you do? You would let? Lovely. Okay, so for your x-intercept, you would let y be equal to 0. So you're going to take y, which is f of x, and you're going to make it equal to 0. And then you would factorize, wouldn't you? And we all know how to factorize trinomials. This one is a particularly easy one. And we would say there's an x-intercept at -2 or there's an x-intercept at -1. All right. So when it comes to us drawing our parabola, I don't know what this particular parabola looks like, but let's say it looks something like that. And your -2 would be over here, and your -1 would be over there. And there would be two x-intercepts. Okay, there can be two x-intercepts, or if you had a parabola that had its turning point on the x-axis, then there would be one x-intercept, right? You are doing the same thing here. Okay, when you are solving a cubic equation, right? In other words, you are taking these expressions we've been working with and you are making it equal to 0. So let's say we had a cubic equation that was, let's just scooch over to the side here. Sorry, as I say, I haven't got my mouse. I'm feeling a little bit. Okay, a cubic function looks like this. So if that's our set of axes, right, a cubic function is shaped like this. Well, this is one of the shapes anyway. We're going to talk about this. So if we want to find its x-intercepts, can you see that there could be up to 3 different x-intercepts? Right. So when you are solving a cubic equation, it can have 3 x-intercepts, or it could have 2 x-intercepts. All right. So in other words, what could end up happening is that your graph could have a turning point on your x-axis. So for example, your graph could look something like this. Oopsie. So it would come down, touch, and then it would do something like that. Okay. So here there would be 2 x-intercepts. Or you could have a cubic function that has one of its turning points above the x-axis. So in other words, it could look something like that. In this case, it only has one x-intercept. So when you are solving a cubic equation, there can be at most 3 real solutions. There can also be 2, and there can also be 1. Okay, it just depends on the particular cubic that you have been given. All right, so when you are solving an equation, you are taking f of x and you are making it equal to 0. So if we have a look at just the simple example over here, all right, if we wanted to solve this, it would be easy. 2x cubed plus 5x squared, we would need to move the 3x over to the other side. In this case over here, we could factorize out the x as a highest common factor. That would leave us with 2x squared plus 5x minus 3. So now we would leave x on the outside. We'd factorize our trinomial. And we've got 3, so that would give us plus 6 minus 1 to give us our plus 5. So in this case, this has 3 roots. Either x is 0, or x is equal to 1 over 2, or x would be equal to -3. Okay, so it's just a matter of making f of x equal to 0 in order to be able to solve your cubic equation. Okay, so sometimes you're going to have to use the methods that I've shown you, all right? But in this particular question, we could have taken out the x as a highest common factor.